Hi, my name is Pernille Gøtz. I'm the inventor of the hydrogen game and I'm from the Technical University of Denmark. The hydrogen game was developed in the EU project Green Skills for Hydrogen as a tool for teachers to facilitate dialogue about the complex energy systems where hydrogen will play a role. So today we're going to play 3 games. It's all within the hydrogen game. It's gamification in the sense that we don't know yet what will be on the board. And the first game will most probably not be very long. The second might be a bit more challenging. And the third one is often the one that people find the most interesting. But the first one is trying to put up the icons in what we call the energy value chain. And here on the board, if you look to the board, I have put already kind of a table. It says non-renewable down here and renewable. Then we have here energy source. That would be the beginning of the energy value chain. Where are we getting the energy from? Then there's one called harvesting. How do we get the energy from wherever it's coming from? Energy carrier. That could, for example, be battery or other things. Something that can carry the energy that we have harvested.
And the TSO.
Yeah, but that's a good point. The transmission system operator. That's an important part of this value chain.
Yes. Yep.
But is it a carrier? Or how can we, what do we define by carrier? I think this will come up when we start discussing.
Okay.
And then storage. We used to call it transportation, but also how do you store this energy that you have harvested? And then finally, what can you use it for? Because different types of energy can be used for different things. Yes. And then down here we have 31 icons that are all to be placed somewhere in this system. Okay? And some of them will be very evident where they're going, and some of them will be more problematic. But the first task I want you to do is, in collaboration, putting these icons up in this value chain. And I want you all to agree on where you're putting things. And if you cannot agree, it's okay. But try to discuss until you agree. And if you do not agree, it's okay. We will take that up in the end, okay? But I will give you about 5 minutes for this. Okay. So please get started. So thank you very much. You put up all the icons. I see several interesting things here, perhaps also some corrections. But there is one, I wouldn't call it a fault, maybe it was a challenge from my side, which lies in this storage transportation here. Because transportation, you've put a lot of the icons that are
actually they're for usage. Maybe. They're for usage.
It's exactly usage.
Yeah, they're not storage. Yeah.
It's not storage. So if we look away from the transporting thing and say storage, if I just say that, would you do something differently?
Yep.
Maybe. Maybe? Yeah? How would you do it differently? You're welcome to move it.
So cars go here, ships, trucks, trains, aviation.
Yeah. Yes, okay. I would say now because these are some of the interesting applications, right? Yeah. Also, you have both electrolysis and fuel cells. No, let me start another place. I think you did very well on putting up the different types of energy sources. Is it a renewable energy source or a non-renewable energy source? Hydropower, wind, sun, biomass, and so on. Cool. So what we just did here with the game, the first game, the energy value chain, is that participants are getting familiar with the icon concept. And also I introduced the game in a manner so that they all felt they could contribute, that any kind of knowledge is relevant. And as you saw, some of the icons were more easy for them to put in the value chain than others. For example, the sources are often the most easy, but then when it comes to the applications, the carrier technologies and so on, it's a bit more complicated. Also, you saw that I called the storage solution transportation also, and it gave some confusion. But when I as a teacher said, what if we define storage as something that can actually store the energy, they were all like, of course it's applications, it's not means of transportation. So in this way, via dialogue, like first the participants had a dialogue in the group about their understanding of the icons. And while they were discussing, I was watching what are they doing, how are they moving it, and I could see, there are some problematic placements, but also some that could be discussed. So in the following up, I engaged with the participants in a way so that they could see that some of the icons are difficult to place because they can be in several places in this value chain. And this is very difficult to explain in a lecture normally, that something has more functions. So now they, with this first game, they both have an understanding of the concept with the icons, and they have a better understanding of the hydrogen value chain, which makes a good basis for moving on to the next game, which is the hydrogen production paths game. You will be making the production paths of green hydrogen, gray hydrogen and blue hydrogen. Have you heard about the different hydrogen colors before?
Yes.
Yeah? No? So hydrogen can be made in different ways. We want to make renewable hydrogen, but it's important to know that there are other ways to produce hydrogen also, which is already being produced today in large amounts. And to understand why it's difficult to make the renewable hydrogen, it's important to know these colors and know how it's produced. And this is the purpose of the second game, the hydrogen production paths, or the hydrogen colors game. So in a minute, you will get an opportunity to finish as many of some tasks that I have here on the computer and on a paper. And I want you to make the value chain for green, gray and blue hydrogen. And you get 1 point for each correct color. And I want you to choose the 2 currently most employed use cases for hydrogen. So if you choose the same as me, you get 1 point per use case. And if you have a reliable reference for your choices, meaning that it's some good institution that is saying this is how much hydrogen that is being produced, you get 3 points. So this is an important one to focus on. And then the final task is that you should write the chemical equation for the conversions happening for each color. You get 20 minutes.
Okay.
Okay. And also one final point, you use the icons, but you're also allowed to write on the whiteboard. Okay? Now we've done the hydrogen production paths game. The participants have had 20 minutes to do all the different tasks that I had decided for them to do. And in this round with these participants, it has been clear that when you're doing this production paths game, you should consider what assignments you give the students. So I have a mixed group of participants here. Some are from biology, some are from chemistry, meaning that their prior knowledge about hydrogen is very different. And so this is a more nerdy game. I would say it's mainly for students within chemistry or engineering and so on. But I would still say that for everyone, it's very important to do some version of this game to highlight that there are different hydrogen production paths, and also to highlight that currently it's less, it's 0.1% of hydrogen globally that is being produced as green hydrogen, to show that there is a long way to go if we want to have green hydrogen at scale, and also to show that hydrogen, when being produced in other paths, has other qualities than the green hydrogen. So there are many important discussions within this. As a teacher, you can find out what tasks you want to give your specific group of students or learners.
Okay, so we use the icons for the production paths of 3 different types of hydrogen. The first was green, so we use the icons of sun, wind and hydropower as the sources, and there are different conversions, for example through windmills, electrolysis or solar panels, and then we have the green hydrogen. And for the other 2 types of hydrogen, there are some common things, so we use these icons. For example, the natural gas that is used for both of blue and gray hydrogen, and also there are some common conversion process through steam reforming and extraction. And the main difference between these 2 types, one is the CO2 capture. So when we have the CO2 capture, we have blue hydrogen, and without capture, this is gray hydrogen. And again, there is a common icon for both of these types of hydrogen, that is the gas container. So in this way, the production path of these 3 types of hydrogen is completed.
So in this last game, I've chosen 3 applications: aviation, shipping and trucks, hard to abate sectors. And I would like you to make the value chains backwards for these chosen applications in a scenario where they have to be decarbonized. So we are past, as much as possible, using fossil fuels to fuel these applications. And now I want you to come up with the ideas for how to fuel these applications in a decarbonized way. Okay. Yeah? And you are, as in the previous games, allowed to use all the icons. You are allowed to draw and write as much as you want. You can invent new icons or drawings, as long as you're trying to make the full value chain for these applications. And you get about, let's say, 10-15 minutes.
Perfect.
Okay.
Yeah.
Okay, thanks.
Okay.
Okay, so in a nutshell, what we did was discussing the end usage aviation, ships and trucks, and we decided with storage we can use liquid fuel, batteries, fuel cells also, and as energy carriers we have different types, because we have mostly green hydrogen, but it goes as RFNBO, which is a renewable fuel from non-biological origin, and it
Actually, we had a discussion while we were looking at your work, because you started out just putting SAF and this renewable fuel.
Yeah.
But to produce SAF, you actually need a CO2 source.
Yeah. Yeah.
So it's both. Where do you get this? How do you get this CO2 that you need to produce this? That's one thing. And then how renewable is this fuel actually when you have to incorporate this CO2?
Actually,
that's a discussion. So in this session, we've just seen how the participants, after playing game 1 and 2, have gained some experience with using the icons and the concept of this board. And I gave them the task of trying to come up with a solution to how they could decarbonize 3 applications that I chose I think is interesting for this class. And they got 10-15 minutes to come up with an idea. And in this particular exercise, they are drawing on their existing knowledge. If I wanted them to come up with more innovative ideas, I could give them even more time and give them the task of finding research and reports and other stuff where it becomes more concrete what they're building their ideas on. But in this task, they're building on their existing knowledge, and they came up with some very fine solutions. And the discussion, I wanted it to go in the direction of saying that the solutions they're having are not fully green, so to say, not 100%, and that's an important discussion to have. And that's also part of the purpose with the game, that you realize, oh, we're talking about green fuels and so on, but it's actually very difficult when you're looking to the applications to make it 100% green. Overall, the hydrogen game can be used to both dream about future scenarios where all our energy systems are 100% green, but it can also be used to be more realistic about what is possible now and how much CO2 do we still need to use, even though we want the green technologies. Across the EU, these days politicians and experts are discussing how the energy map of Europe should be. And the discussions can be at many levels. And the hydrogen game shows that it's important to be able to discuss all the levels at once without losing oversight of both the specific technologies and the systems as such. And this is a tool to facilitate this dialogue.
So hydrogen game was a really interesting experience. Even when you think you know a thing or two about hydrogen and chain value, certain problems are coming up, especially in a discussion with the other participants. And I think it's really helpful to understand how complicated actually the future hydrogen economy is and will be. So yeah, I definitely recommend. It's a very interesting experience.
So I would say that the hydrogen game is really interesting because it brings discussion with people from different sectors. And actually you see that it's not so easy to go fully green and fully renewable. So we need to do it step by step, but I could say there is a bright future. So I definitely recommend this game.
The hydrogen game was a nice and interesting experience for me, and what I believe that it is a very helping tool for teachers if they use it in their lectures or in the different practical activities. So the students can get the ideas and about different processes which are involved in hydrogen, and what they can do, how they can contribute for the decarbonization of different processes and for the improvement of green technologies. The aspect that I liked from this game, that the visualization is very quick. It does not take time. Students, when they have a lecture and they have to visualize things about the thesis, it's a very time-saving opportunity for students. So it's a very quick and very interesting way of learning.
The game can be used for many contexts, for schools, for students in universities, PhD students, for facilitating dialogue among policymakers and project managers of hydrogen projects, and also for involving experts in these dialogues. So the main value of the hydrogen game is that it's a tool that makes it possible to discuss the connections between the many different elements that our energy systems, our current energy systems, and our future, for hopefully more green energy systems have. All materials you need to play the game can be downloaded via the link below. The materials are free, easy to download, and easy to print out and use in your classrooms. And please just get started and have fun playing the hydrogen game.